So this is my second example. So now for this also we have to find the eigenvalues. Okay, so you can directly, so just solve as many problems as you want, guys, because practice makes man perfect, right? So if you solve more example, then you can write directly. Okay, so here what is the characteristic of this one, which is equal to 0. So here this is what my given matrix is A. Okay, so A minus lambda I, your A is what? 0. 0 minus lambda I means what? Lambda minus lambda, and which is I, and this is what? This is minus I, and this is what? This is a minus I. Okay, so now you have to take the determinant of this matrix. Lambda minus lambda into lambda is lambda square, and this is what? Minus I into I is what? Which is a minus of I square, which is gives you what? 0. Okay, so here you know the value of I square, which is nothing but what? Minus 1. Okay, therefore lambda square minus of minus is what? Plus. Minus of minus is what? Plus. So 1, which is equal to what? 0. Okay, so next just look at here. So lambda square minus 1 is equal to 0. Then if you solve the equation, you will get square root of 1, which is nothing but what? Lambda is equal to plus or minus 1. Therefore eigenvalues are what? So here also eigenvalues are nothing but lambda 1 is equal to 1 and lambda 1 is equal to what? Which is a minus 1. Okay, so next let us move on to third example. Okay, third example I'm going to take here only. So in the third example, I am going to take a matrix A as 0, 1 and minus 1 into 0. Okay, so just write the characteristic of this equation. So what is the characteristic of this equation? A minus lambda I, which is equal to what? 0. 0 minus, this is a lambda. Okay, 0 minus lambda means minus lambda. You will get here 1, you will get here minus 1, and you will get here minus lambda, which is what? Which is equal to 0. Now you have to take the determinant of this matrix. Lambda minus into minus plus, and lambda is what? Lambda square. Minus into minus what? Which is plus, and which is what? Which is a 1. So now you have to solve this equation. Lambda square is equal to what? Minus 1. Okay, so lambda is equal to what? Square root of minus 1. And we know the value of square root of minus 1. So what is that? So square root of minus 1, which is nothing but plus or minus I. Here your eigenvalues are in complex. Okay, therefore eigenvalues of A are what? Are lambda 1 is equal to I and lambda 2 is equal to minus I. Got it? So like this we have to solve the eigenvalues. Okay, so next we will take another fourth example. Okay, so this is what? 0, I and I 0. Okay, so how we have to solve this? First take the characteristic of this equation. A minus lambda I, which is equal to 0. Okay, so A is 0, lambda means, so directly I am going to write here, so which gives you minus lambda, which is I, and which is what? So this is also, and this will gives you minus lambda. Okay, just to take the determinant, lambda square minus I square, which is equal to what? 0. And you will get like this. So this is what? I square. It means into I is what? I square minus, what is your I square? I square is nothing but minus 1. Okay, it means I square is equal to plus 1, which is equal to 0, lambda square, which is equal to minus 1, and lambda is equal to what? Square root of minus 1, and lambda is plus or minus I. Therefore eigenvalues of my given matrix is what? given matrix, eigenvalues of given matrix, these are what? Lambda 1 is equal to I and lambda 2 is equal to minus I, plus I and minus I. For this I will get a complex eigenvalues. Okay.